Hi everybody, I start third lecture about modern periodic table. As you know, periodic table, the new periodic table or modern periodic table uh, is created by the Mendeleev, is the Russian scientist. In the modern periodic table, the base works with the atomic number. As you see here in the periodic table, hydrogen with atomic number 1 is the first element. Okay, and then the helium in this row. The second, okay, hydrogen has 1 proton and the atomic number is 1 proton. And the third one's lithium, beryllium, and in this direction increase the number of the atomic number or number of the proton. And the direction goes in this direction. As you see here, this periodic table, the base works with atomic number. In the horizontal row is the period. For example, is the first period, second period, third period. The same shell is filling up, okay? And the first period is the N is 1 is the K shell. Second period, N is 2 is the L shell. And the other one, vertical column or group, is the valence shell configuration the same. As you see, valence shell is the last subshell or last shell which electrons start flying there. And it has similar chemical properties. For example, it is the first group, second group, and we will see study, we can continue from the left to right. As you see here in the periodic table, I put here, for example, start from here. As you see here, we can group counting from the here 1, 2, start from the transition metals, and go continue with the pure orbital fling, okay? Or we can say V1A, 2A, and we start 3B, and also we continue 3A until the 8. Okay, mainly we say in the groups, first group, second group, third group, fourth group, fifth, sixth, seventh, eighth group is the noble gas. In the every data we can find some information. It is atomic number, it is atomic mass, and oxidation number, and electron configuration, and which is studied before, and also if you see, atomic mass is here, and it's electronegativity. And also we can find many information. If you see here, you write here in here, if you see, and but it's in the German language, but no problem. It's oxidation number here, and electron configuration, and it is electronegativity is very important. And number 3 is the relative atomic mass. Number 4, it is the boiling point or melting point. It's very important. It's here. For example, here's the hydrogen. You start atomic mass, melting point, and the boiling point. Okay. It is a melting, it's boiling, it is electronegativity and oxidation number and electron configuration. Okay. Now we go continue. Here is very important. Main groups which we have. The first group is the alkali metals. The orbital of S is start with 1 electron, NS1, and the second alkali earth metal. Third group is the boron group, carbon group, nitrogen group, oxygen group, halogen, and noble gas. Here is the s orbital filling, which just we have a alkali and alkali earth, and we have a pure orbital group in the 6th number from the boron to the noble gas. Okay, and here is the transition metal, and the last one is 2. It is the f orbital filling. It is the transition metal. It's the orbital filling. It is the f orbital filling is lanthanita and actinita. Group numbers number of the valence electron, okay? In the s orbital, we have a s orbital, it's black, we have just 2 electron maximum. One is here filling, second is here filling. In the alkali earth, it is a full, so s orbital is full. But in the p orbital, we have 6 orbital, 6 maximum electron in the 3 orbital of the p. It is a 1 electron, 2 electron, 3 electron, 4 electron, 5 and 6 electron in the p orbital. And the d orbital is the 10 electron maximum, start from the 1 to 2, if it's 1 to 10. And the f orbital is start from 4, maximum 14 electron with the 7 orbital. Okay, 7 orbital, 14 electron. It's the 5 orbital and 10 electron. As you see here, transition metal is the d block. Maximum 5 orbital and 10 electron, 2, 3, 4, 5, 8, 10 electron. And it is a transition metal. Its F block is the lanthanides and actinides. And it has a 7 orbital and 14 electron maximum can have this group. One of the important things, we have a metals, nonmetals and metalloids. Metalloid is the semi-metal, or how we can have property of the metal and can have a property of non-metal. It can have both of them. But the most important things in the periodic table, if we go from the right up, is the most non-metal property, and the left down is the most non-metal property. And the metalloid is in the middle. Start from the boron and the silicium, and if you see germanium, arsenic, and these elements has the metalloids or semi-metal. And we can say the francium has the highest metal property. Periodic table properties. How the periodic properties? I spoke last time about the atomic number effect in the periodic table. It is a principle in the periodic table. And the physical and chemical property can be vertical. If you see, we can classify 4 different properties which it is the first one, atomic radius, the second ionization energy, electron affinity, and electronegativity. Now we go study about this part. It is very important. The first one, radius. Atomic radius in the period from the left to right decrease. Why? As you see here, for example, in the last shell, lithium has a 1 electron in the last valence shell, and the barium has a 2, boron has a 3. And if you see here, if the number of the electron in the last shell increase, the valence shell increase, the attraction of the electron to the nucleus is increasing, and then the radius increasing. But from the up to down, okay, the radius increase because of the number of shell increasing, because it is we have just 1 shell. Here is if we have a 2 shell, then radius will be more here. But if you see here, you have 1 electron, it's a 2 electron nucleus, and we have, for example, 8 electron here. Then attraction for the nucleus will be very. And now we can say the smallest electron, we can say it is a helium, and the biggest radius is the cesium or francium, because it's the last, because it doesn't drop. There are 7 groups with the radius. But other important things, atoms with cation. For example, sodium, with the loss of the 1 electron, become the cation, and it become the noble gas before it. If you see here, here's the sodium. Here's the sodium. If the sodium loses electron, become the electron configuration is the neon. You see, because it has the 1 shell decreasing and become the electron configuration of the noble gas before it, and it will become neon configuration, and it will be decrease the shell number, and because of it will be radius decreasing. But if we have increase the electron number, okay, in the anion, the color accept the electron, becomes Cl minus. In the Cl minus, the radius increasing because the number of electrons increasing. It is very important. Okay. We go to the ionization energy. ionization energy, we have a first, second, third ionization energy. The most important, the first ionization energy, energy need to remove the most loosely bound electron from the natural atom in the gas. It's very important. If you see for the losing electron is very important. Well, in the periodic table, if you see it, how is it possible? Noble gas is the highest because first ionization energy, because it is very high stability. If you see here periodic table, I open the periodic table here. If you see here is the most stable because they are valence shell is the full. Okay, they are stable in the atomic shape, and we don't have and we can find in the simple element shape helium or neon or argon. Okay, in the last valence shell they are full 6 electron in the p orbital. They don't like to lose electron. Okay, but the alkali metals, because it has 1 electron, they like to lose 1 electron and become the noble gas before it. For example, lithium like loss of electron become helium. And it is very important since the noble gas are the highest ionization energy and alkali the lowest. Then also from the left to right, the first ionization increasing, and from the up to down decreasing. But the problem is that one is very important. There is a small exception. When we start the filling, when we have a Hund rule or the half of the orbital start to filling, for example, for the nitrogen. Nitrogen in the last valence shell, it has a 5 electron. If you see here, this is the nitrogen. Okay, it is a half field. Okay, in this case, first ionization energy, it is higher than oxygen because it has a high stability. It is just a small exception because in the oxygen, it is a 1 electron more. It will be like this shape. Okay, as you see here, 1 electron more here. It's because of the half shell is almost like high stability, like noble gas with the full field of the p orbital. Because of this situation, oxygen group, and also in the alkali earths we have a 2 electron in the first. It is more stable than, for example, barium more stable than boron in the third group because it has a 2 electron and the 1 in the p orbital. Then the losing of this electron very easy. It is an exception. It is a full S. Okay, for example, magnesium, and we can go calcium and other. You see, it's very small. And also sodium and the phosphor. It is one of the most important. We can see here, it is some exception we can remind here in these elements. Okay. And but usually we accept this rule mainly which increase ionization energy from to left to right and up to down. Electron affinity, it is the energy change for the process of adding electron to the nature of atom in the gas state. Okay, it has a 2 direction. It has a positive and a negative. Okay, in the positive direction we have a alkali earth because if the full s orbital it's hard to add, and noble gas because they are full and adding electron for them is very hard. And the negative, highest negative, it is the halogen because they like electron to become noble gas. They love the electron because it is very easy and we can really add it. And in the system of periodic table, we can say if we go from the down to up increase and from the left to right also increasing. But they say it is the unit is a joule per mole like other. The electron affinity is either positive or negative. We can have the both direction. Electronegativity, the measure the ability of an atom to draw bonding electron out to itself, or the Pauling scale, how much atoms has the effect to get the electron, ability to keep the electron and like the electron in the bond, not alone. For example, if we have a HF, most of electron go to the direction of the fluorine, and we have this partial negative fluorine and partial positive hydrogen, and most of this bonding electron will be going around the fluorine. Fluorine has the highest electronegativity. Okay, because noble gas cannot make a bond in this case, usually we cannot compare the electronegativity for them, no electronegativity. Then fluorine is the highest. From the fluorine to the left side decrease. From the fluorine to downside also decrease electronegativity, and then we can say francium is the lowest electronegativity in this periodic table. And it was the last lecture, last part of the third lecture. I hope it will be useful for them. And as I mentioned, you can find information of every element in the periodic table: atomic number, atomic mass, boiling point, melting point, boiling point, and electronegativity, oxidation number, and electron configuration of atom. I hope it will be useful, and see you in the next lecture. We continue with you. Thanks a lot. See you.